Hello, welcome to Lesson 4 of Maths in an Empty Classroom with me, Mr. Sutton. Today we're going to be looking at statics of rigid bodies, and this whole topic is to do with resolving forces and moments. So if you're happy with how to resolve, you're happy with how to do moments, you're going to be okay with this. Things that we need to consider about this: static, it means it's not moving. So the body itself is stationary. This is generally to do with rods, they're not moving. The reason they're not moving is that the resultant force in any direction is zero, and generally we're talking about either vertically or horizontally the force is being balanced. Similarly, the resultant moment is zero, and what that means is that you can pivot on any point along the bar and the resultant moment, clockwise, anti-clockwise, they'll balance out to zero. So that's the things that we need to know to be able to do these kind of questions. What I'm going to do now is just take you through example 1. We'll just begin by talking about some of the language that's being used and some of the assumptions that we make as a result of that language. The rod is uniform, and what that means is that the weight is going to act at the centre of the rod. We have rough horizontal ground, which means there's going to be friction at the point A between the rod and the ground. We have a smooth peg C, which means there isn't going to be any friction between the rod and the peg at C. So one of the situations has got friction, the other hasn't. We'll look at that in the diagram in a minute. The rod is in limiting equilibrium. Limiting equilibrium just means that the forces are balanced, so it's on the point of moving because the forces are perfectly balanced with each other at an angle of 15 degrees to the horizontal. Right, so let's begin by drawing out a diagram, because to solve mechanics questions you absolutely have to draw a diagram, and that is not a challenge, that is a statement. So here we go. We have rough horizontal ground, we have a uniform rod AB, and we have a smooth peg that the rod rests on. Sometimes people struggle with how to draw that diagram and interpreting what the smooth peg is. It's just imagine something cylindrical sticking out of the wall and you're just resting a bar on it. That's what's happening. It's no more complicated than that. The rod is AB, so we've got point A, point B, and it rests on the smooth peg at C. And the angle given was 15 degrees. Right, so let's now start to consider the forces that are acting on this system. We have the weight of the rod, so what I'm going to do is draw a point there and draw the weight going directly vertically downwards, and that is 40 G. And as you've seen me do in these videos before, because that force is not acting parallel to the plank, I'm going to draw in dashed line there, because I know that the angle formed is going to be the same as the angle that the rod makes with the plane. Because this is a uniform rod, I know about the distances that these are away. So up here I'm just going to draw the same length line, and I'm just going to split it into the distances that I know. So this distance here is 5 metres, because it's half the length of the rod, because it's uniform. I was also told in the question that AC is 8 metres. Okay, so if AC is 8 metres, then that means that the distance between this point here and this point here must be 3 metres, making 8 metres total, and then the distance up to the end of the rod is 2 metres, making my total of 10. Now let's consider forces acting on the system here. We've talked about the weight of A. What we're going to need eventually is we're going to need the component of this force here, but we'll deal with that later on. At the point A, we have two forces. Because we have contact between the end of the rod and the ground, there must be a reaction force at A, and that reaction force will act perpendicular to the ground at the point where A is in contact with the ground. And I'm going to label that reaction A because there's another reaction force which I'm going to label, so I don't want them both to be labelled R. Also at A, because the ground is rough, we're going to have a frictional force. We have to consider which way that friction is going to go. And the way we do that is we think, okay, if this system is in equilibrium, if it was going to move, what way would it move? And how it would move is it would slip down like that. Okay? It would slip down the peg. So if it slipped, that means that A, the end of the rod, is going to go that way. So if it's moving that way, friction must be going the other way. So I'm going to get a slightly fatter pen so it shows up over the black one. And label my friction force there. The other force that I have to consider is that I have a reaction force at C, where the rod is in contact with C, and I'm going to label that RC. There is no friction at that point because we were told that the peg is smooth. So those are the forces that I've got so far. Now, knowing what I'm going to have to do later on, in the same way as I drew a dashed line in here that was perpendicular to the rod, because here I have a force that is perpendicular to the rod, but I know that later on I'm going to need to know the vertical component of that, I'm going to draw in my dashed line here, like so, and again, the reason for doing that, let's just make that actually look vertical, the reason for doing that is I know that that angle in there is also 15 degrees. Same as that angle. So I've drawn my diagram, I've labelled my forces, now let's look at what we're being asked to do. We're being asked to find the magnitude of the reaction at C. Now, with any of these questions, you're going to be doing three things. You're going to be resolving vertically, you're going to be resolving horizontally, and you're going to be doing moments. Those are the three things that you're always going to have to do as part of these questions. So if you're ever not sure what you're supposed to be doing, do all three, and you should find that by doing them, one of them gives you enough information to work out some of your unknowns. But I know that what we're looking for is the reaction at C, and the best way to approach that is to take moments about the point A. Now, why choose the point A? Well, when you take moments about a point, you can ignore any forces that are acting at that point, and because at the point A I have an unknown reaction force and I have an unknown friction force, by taking moments about A, I've eliminated two forces that I don't know straight away. So what I now need to do, moments about A, I need to think, okay, I need to do my clockwise moment equals my anti-clockwise moment. So I need to think about any forces that are acting clockwise if I go like so. And you can probably see by me doing that this force here is causing the rod to want to turn clockwise, so I have to consider this one to start with. Now, the issue that I've got is that this force is not acting perpendicular to this distance, and a moment is force times by perpendicular distance. So what I always like to do is think, okay, let's take this force and draw it so that it's perpendicular to the point that I'm pivoting about, and what I need to do is I need to find this distance here. My preference with moments is always to resolve the distance rather than trying to resolve the force. Let's get that right. Clockwise equals anti-clockwise. force is 40G multiplied by the perpendicular distance, which is going to be 5 cos 15. I know the 5 because it's the distance from A to this point here, cos because it's adjacent, so cos 15, and that's going to equal my anti-clockwise force, which I get from doing that one there, RC, which is trying to make it go in an anti-clockwise direction. Now the bonus here is that RC is acting perpendicular to the point where I'm pivoting, so I don't need to do any resolving. I can just say that it's RC, the force, times by 8, which is the distance that it is away from A. So 40G times 5 cos 15, so we'll work that out as a number. In degrees mode, remember. So we've got 1,893.21, keep that in my calculator, and that equals 8 RC. So dividing by 8, I get RC to be 236.65, which to 3 significant figures, RC is 237 newtons, and that is part A done. I'm going to store that value in my calculator for future calculations. Right, now let's have a look at what we're being asked to do in part